AMD says it is acquiring Taalas, a Toronto chip startup with an unusual idea. Instead of streaming a model's weights from memory, etch them straight into the silicon. The reported speed gains are dramatic. So is the catch. Here is what that actually means. A normal AI accelerator stores a model's weights in fast memory and streams them through the compute cores over and over for every token. Taalas takes a different route. It builds what it calls model-specific integrated circuits, where the weights are physically etched into the chip. The model is not loaded onto the hardware, it is the hardware. Per the write-up, the chip has two main regions. A mask ROM fabric holds the model weights, fixed permanently in silicon. An SRAM fabric holds the changeable parts, the key value cache, and small fine-tuning adapters. Because the weights never have to be fetched from external memory, the usual memory bandwidth bottleneck largely disappears, which is where the throughput gains are claimed to come from. The claims are bold. On its HC1 chip, a 6nm part shown in February, Taalas reported serving Meta's Llama 3.18 billion model at just under 17,000 tokens per second, which it framed as roughly 48 times faster than a GPU, and about 8.5 times faster than a Cerebrus part at the time of announcement. A follow-up chip is said to target 20 billion parameter models. The obvious cost of baking a model into silicon is that you cannot change it. A new model, in principle, means a new chip. Taalas softens this by saying an update only rewrites 2 layers of metal, rather than starting from scratch, which cuts the cost and time of a respin. Still, this is hardware for a model you have settled on and plan to serve at enormous volume, not for something you tweak every week. For AMD, this is a piece of a larger strategy. The company plans to pair Taalas-style chips with its Instinct-based Helios racks in what it calls a disaggregated inference architecture. Different silicon for different parts of the job, rather than one general chip doing all of it. As AMD's AI lead put it, the goal is a full-stack platform that lets customers pick the right compute for each workload. Terms were not disclosed, with the deal expected to close late this year, pending approval. The takeaway is a familiar trade-off in a new form. Give up flexibility, get efficiency. Freezing a model into silicon can, if the claims hold, deliver huge throughput per watt for a fixed model. Those numbers are the vendor's own, so treat them as claims until independently tested. But the direction is worth watching, because it suggests the future of inference may not be one chip for everything, but specialized silicon for the models we run the most. Now you're one step ahead. Subscribe to BirenAI to stay there.